Alright, so we've generated a series of points along our creek shapefile. Now let's extract the values from the raster DEM that we have generated this hillshade from to those points so that we get an idea of how the slope of the river changes along its course and as it crosses the series of faults that we looked at in the Long Valley area and will continue to look at this summer. So I'm going to go to the Tools section. I'm going to type extract, and I see a bunch of other ways to extract data, but I want to extract values and I want to extract them to points, so I'm going to use that. I'm going to select this extract values to points thing. My point features, right, are those points that we just generated from our Hot Creek shapefile. The raster that we're going to take values from is the DEM. The place we want to save that is not the default location. Instead, I'm going to save that to my creek thing, and I'm going to call it HC Hot Creek Extract. Okay, let's go. Thinking. We'll know it's done thinking because we'll see something show up in our layers palette here. Just know this is as much fun for me as it is for you. Here we go. We have a little indication that things are actually working here. The program is alive, and a new file comes up. Let's just double check that that's actually right. We have now added this column raster value since the value we extracted since the raster we extracted these values from is a digital elevation model, those correspond to elevations, and in such that it is a river, and rivers flow downhill, we'll see that these values decrease systematically downhill. That's great. Now to actually plot this in a useful way, what I want to do is go up here to Table Options, and down to Export. Stopping real quick, sometimes you're going to want to add a field to a data column, like maybe I'll want to add a field right now called horizontal dist for horizontal distance, and I'll click OK. Oh, the title is invalid. Let's just accept their title, and you'll see now I've added this other column. Now you can only add fields when you're not actively editing a shapefile. When you're actively editing the shapefile, you can change the values, which I cannot do now. What you can't see is I'm hammering on my keyboard and nothing is happening. But what we can do is export this to a program that is easier for us to use. We want to export all records. Navigate down to this Browse button, and that's going to let me choose the type of file that I want to export, where I want to export it to, which again is going to be my Creek file. I'm going to call this Hot Creek Long Pro. And I'm going to go ahead and save that. Now, a text file of a table like this is generally going to be delimited, which means that the values in the different columns are going to be separated by either commas or tabs. Sometimes files are space delimited too. Let's go back and actually find that file. I'm going to go into Windows here, Documents, scrolling down to the Y drive. This will obviously be the same for you guys. And in Creek, you will see I have Hot Creek Long Profile. So this is an important place to demonstrate the fact that each shapefile that we make, while ArcGIS only saw the shapefile HC Hot Creek, is these 5 files, right? One of them is actually titled shape. One is .dbf. This is like a database file. It's the table that's associated with Hot Creek. One is this .prj. That's, I think, projection information for Hot Creek. And then I have no idea what the heck those two are. So it's generally a bad idea to mess with ArcGIS files in Windows Explorer because you've got all these things to deal with, right? While my naming convention seems to make sense, all these things kind of look the same here, and it'd be easy to put one in the wrong spot. So let's instead go down to our something regular. And let's see if we can open that with the notepad, and it will show us that we sure enough have a table, which it doesn't look like now, with these different column headings to it, and then all these values. We can see our values of elevation decreasing down the trend of the river. And these commas are separating the different columns, right? So we have FID, ID, raster value, and horizontal, all separated by columns, and the same number of commas delineating columns in the data down below. Now at the end of each of these is a return carriage, which tells whatever program you're opening to go to the next row, and then the commas are telling it to go to the next column. So let's go ahead and open up Microsoft Office. Looks like I may or may not have purchased Microsoft Office. Oh, I have to use Microsoft Office 07, I'm finding out. That's wonderful, because we all love to use Microsoft Office 2007. Wonderful program, doesn't take up any extra memory at all. Now what I want to do is go to Open, go down to that Y drive, and I want to find the shape for the long profile that I just created. Look, it's gone. That's because I don't have text files enabled, and because I'm in the wrong folder. Comes up with this, which is asking me how it knows what should be what. I'm going to tell it this is a delimited file, and that the delimiters are commas. And then I can finish. FID and ID, those are useless. I'm just going to delete those. Horizontal, that's what we want. But I'm going to make a new file that is that, or a new column. I'm going to call it X. I'm going to call raster value Z. The way I know my spacing between these things is I set it, right? It's every 100 meters. So I can set a couple things and then double click the bottom to fill in the rest of the cell. If I select both data files and go to make a scatter plot, Excel is smart enough to know that the thing on the left is what I want for my x-axis, and the thing on the right is what I want for my y or vertical axis. And we see this nice change in slope in the middle of the long profile here, which will correspond to some interesting stuff on your map. There's also this more subtle thing right here. The noisiness of the long profile here is just a function of how the long profile was generated. I did all this painstakingly by hand. It was a little bit lazier for this part, and the results show that. So the other thing that I'm going to want you guys to do when you actually turn these things in is to do some sophisticated scientific doodles that show the orientations of faults on here, maybe a little bit about how much sediment is actually underneath these things, if the sediment thickens anywhere. Maybe in here we'll be actually actively incising into rhyolite flows, which you can see by the violence of my mouse here. But you can all do that by hand. If you really want to, you can actually copy Excel graphs into Adobe Illustrator and edit them that way. Keep in mind the vertical scale here, and that if you draw a fault at what would seem like a normal dip, right, because this is so vertically exaggerated, that dip is much shallower than, appears much shallower on this than it is in reality, right? A 30-degree dip or something, or a normal fault, average normal fault dip of 60 degrees would look pretty damn close to vertical on this figure. Alright, that's all we need to do in Excel for now, or that's at least all I'm going to show you how to do. You can figure out the rest on your own. Let's go back to ArcMap and do a little bit of fault mapping. Let's get our editor on. So we're going to want to do a lot of this on this Hot Creek Color Orthoquad, or Hilton Creek Color Orthoquad Mosaic file. You'll see that I'm now in the Source tab. I don't really, of my table of contents, I don't really like that. I'm going to go back to the Display tab, turn that on. I'm going to turn off my hillshade just because it's taking up display resources. I'm going to navigate down here to where I want to this section here because there's a lot of variety of faulting going on here. Will be good for this demonstration purposes. And we're going to go ahead and stop this video for